Okay, we have here today another integral from the MIT Integration Bee 2025, number 12. We've got the integral of this nested radical dx. Okay, the first thing I want to deal with, of course, is this crazy nested radical where they didn't reduce the indexes here. And I think that's to kind of give us a hint of the pattern, as you see, like, what's happening is the numbers are increasing 3, 4, 5, 6, 7, 8, 9, and then here in the denominator 1, 2, 3, 4, etc. So the first thing I want to do is let's just deal with this radical and try to simplify it. I want to get it out of the radical notation. So like for the first x, it's just under one radical. And so to get the exponent on it, we just want the reciprocal of this. So for the first one, it's just going to be x to the 1/3. And then for the next one, it's going to be under two radicals. And so what I want to do for the exponent on this is take the reciprocal of each of these and multiply them together. So it's going to be like 2/4 times 1/3, but that's going to be 2/12 or just 1/6. So that's going to be our exponent here. And then on the third one, doing the same kind of thing, multiplying these exponents together, but now we need to multiply 3/5 on it. We could write it a different way, but just multiplying it times what we already have. That's going to become 3 over, and let me get rid of this part so we don't confuse it, but we're just taking what we already have, 1/6 times 3/5, and that's going to be and so just multiplying those together, what we get is 1/10. And then doing the next one, it's just going to be the same kind of thing, 1/15. The next one's going to be 1/21, etc. This goes on and on to infinity. So all we want to do to multiply them is just add exponents. So what's going to happen is we get 1/3 plus 1/6 plus 1/10 plus 1/15, etc. So what happened is we ended up with an infinite sum, and we just need to figure out what is this sum going to be, and then we'll have our exponent on the x. So breaking out just the exponent, for 1/3, I can write that as 2/2 times 3. Just trying to get clear on the pattern here. So then for 1/6, doing the same kind of thing, I can write this as 2 times 3/4. Then for 1/10, same kind of thing, 2 times 4/5. And so this is going to go on and on like this to infinity. Well, in order to put this into sum notation, we can kind of focus on this piece right here. So we're saying we've got the sum from n equals 2 all the way to infinity. We always have 2 in the numerator, so we'll write it as 2 over n, and then we have just plus 1, so n times n plus 1. But then for the 2, and this is equal to this, for the 2, I can bring this out front of the sum as a constant. And so let me see if I can squeeze this in right here. So this is going to be 2 out front. Then here, we could do partial fractions, but let's just do it on the fly. So I can write this, in order to get cancellation, I'll just use what we have in the denominator, write it as n plus 1 minus n over n times n plus 1. Just noticing that the numerator, this value is just going to be 1, so we didn't change it. And then from here, let's just break up this fraction into two fractions. So what we'll have is it's going to be n plus 1 over the denominator minus the second piece, n over n times n plus 1. But then we're going to get cancellation here and here, and here and here. So we just have a 1 now in the numerator. So now plugging in, starting with 2, what's going to happen is we're just going to have 1/2 minus 1/3. And then when n is 3, we're going to have plus 1/3 minus 1/4. And then plus 1/4 minus 1/5. And what's going to happen is this is going to keep going all the way to 1 over n minus 1 over n plus 1 as these values are approaching infinity. But because these values at the end are going to infinity, we don't care about these because they're both going to 0. Coming back here, we get cancellation here, 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 cancellation here, cancellation all the way to the end. So everything goes away, telescoping series, and all we're left with is to multiply 2 times 1/2. But 2 times 1/2, that's just 1. So our exponent right here on the x is just going to be 1. So let me clean it up and we'll just get back to our integral. So it turns out this is the simplest integral in the world because our exponent's 1. So we're just integrating x dx. So we go ahead, power rule, x squared over 2 plus c, and that's it. Okay, so there you go. Not really an integration problem, just kind of a telescoping series problem disguised inside of an integral. Thanks everyone for watching. Have a good day.